In chemistry, no bond is purely ionic or covalent. Fajans rules help us predict when an ionic bond will develop covalent character through a process called polarization. We will examine how the size and charge of ions influence this transition. Polarization occurs when a cation attracts the electron cloud of an anion. The cation's ability to distort the anion is called its polarizing power, while the anion's tendency to be distorted is known as its polarizability. This distortion leads to electron sharing. The first rule states that a smaller cation has a higher charge density. Because the positive charge is concentrated in a smaller volume, it exerts a stronger pull on the anion's electrons, increasing the covalent character of the bond. Rule 2 focuses on the anion. Larger anions have valence electrons that are farther from their nucleus and shielded by inner shells. This makes the electron cloud soft and easily pulled toward the cation, favoring covalent bonding. The third rule involves the magnitude of the charge. As the positive charge on a cation or the negative charge on an anion increases, the electrostatic forces strengthen, leading to significant polarization and higher covalent character. The final rule considers the electron configuration. Cations with a pseudonoble gas configuration, having 18 electrons in their outer shell, are more polarizing than those with a standard noble gas configuration because of poor d orbital shielding. Mathematically, we look at charge density. A small radius results in a steep potential gradient. This high density is the primary driver for the cation to pull the anion's electrons into the internuclear space. Let's compare lithium chloride and potassium chloride. Since lithium is a much smaller cation than potassium, LiCl exhibits significantly more covalent character, affecting its melting point and solubility compared to KCl. Comparing tin-2 and tin-4 chloride illustrates the charge rule. The +4 charge on tin in SnCl4 creates such intense polarization that the compound behaves like a covalent liquid at room temperature. Fajans rules allow us to predict physical properties. Increased covalent character typically leads to lower melting points and higher solubility in nonpolar organic solvents, as the lattice energy of the ionic structure is reduced. To summarize, covalency is favored by small cations, large anions, and high ionic charges. Keeping these three factors in mind allows you to predict the chemical behavior of most inorganic salts. By understanding the polarization of electron clouds, we bridge the gap between purely ionic and purely covalent models. This concludes our look at Fajans rules. Generated by Vision Solve AI.